Learning goal 21 is our next one that we're going to take a look at, and it's involving using exponent laws to simplify an expression. Now, we've taken a look at exponent laws in the past, and we've looked at a few of them. I'm going to go over a little bit of review of those as well, and then we're going to kind of use those and try to make it a little bit bigger, and we're going to use multiple expressions or multiple laws in certain expressions. We're going to add a little bit extra to it as well. So let's take a look at a little bit of review. Okay, we're going to look at 3 laws that are mostly review, and then one that is somewhat review, but a little bit new as well, or a little bit different as well. So the first one is that, so number 1 is that when 2 powers with the same base are multiplied together, the exponents, so let's make sure I get that, spell that right there. There we go. The exponents can be added to create a simplified power. Okay, so remember with powers, we have our base, we have our exponent, and then the entire thing is a power. So something like this here, we have 3 to the power 4. 3 is our base, 4 is our exponent. In this case, 3 is our base, 6 is our exponent. Now, when we're doing a question like this here, okay, so if we want to simplify them, again, this we've done in the past, this should be review. Because these have the same base, so they're both a positive 3, and they're being multiplied together, we can add the exponents. Okay, so we can think of it as 4 plus 6 is equal to 10. So this simplifies, let's get that in here, to 3 to the power of 10. And I'll put that over there. Let's move this one just over here, there a little bit. There we go. So 4 plus 6 is 10. So 3 to the power of 10 would be our simplified power. Now, again, we can do that when we're multiplying powers, but they have to have the same base. So in this case here, they both have a base of 3, so that in fact works. The second one here, these both have a base of -6. Okay, so they both have a base of -6, and they're being multiplied together. So again, we can add the exponents together. So 3 plus 2, that's equal to 5. And so our new power would be still -6, and now to the power of 5. So -6 to the power of 5. So all we're doing there is we're changing the exponent, we're putting the 2 of them together, we're adding them together. So that's law number 1. Okay, so that's the first one that we're taking a look at. The second one is that when 2 powers, again, with the same base are divided, the exponents can be subtracted to simplify the expression. So when they're multiplied together, we add the exponents. When they are divided, we can subtract the exponents. But again, we have to make sure that they have the same base. So here we have base 4, and we can then subtract our exponents. Now again, we have to subtract them left to right. So we're going to do 4 minus 2, and it's not because 4 is bigger. 4 minus 2 is equal to 2. And so we're going to have a new power of 4 to the power of 2. If we do 4 to the power of 4 divided by 4 squared, we're going to get an answer of 4 squared. Okay. Now again, we can do this with numbers. We've done it before. We went. If we go back to learning goal 20 from a little while back, that was a part of it as well. All right, next one here, we have a different sort of division statement. Now we have a fraction. Remember, a fraction is a division statement, and so we can use that to solve. Here we have -6 is both of their bases, and we have exponents 7 and 3. Now 7 is on top, so it's going to be first. So we're going to do 7 minus 3 is equal to 4. And so our new power, okay, our simplified power is still -6, -6, but now it's to the power of 4, and we don't have any more division in there. Now we just have one simplified power. So that's the second law that we have with exponents. So it's our second exponent law. The third one, let's get a different color here, is that if we have an exponent on the outside of a set of brackets, or sorry, an exponent on the outside of a set of brackets can be multiplied to the exponent inside the brackets, simplify the expression. Now, the important thing here is that we have to remember that this only works if it's a monomial inside the set of brackets. We'll get into an example of that in a little bit, and I'll show you kind of why we have to do that, but it has to be a monomial, so just a single term. So what we have here is we have the expression 4 to the power 7 inside of brackets, and then the whole thing is being squared. Okay, so remember this is 4 to the power 7 times 4 to the power 7. And so we can also think of that. So what we can do to make it a little bit simpler is we can do 7 times 2, and that's equal to 14. And so we can then simplify this to be 4 to the power of 14. So now it's 4 to the power of 14. Okay, so we again multiply those two together. So we take the one on the outside and we multiply it inside the brackets to the exponent inside the brackets. The base is going to still stay exactly the same, but the exponent is going to get a bit bigger. Well, most of the time it's going to get bigger. The next one here, we have a base of -5. It's to the power 3, and then we're doing that whole thing to the power 3. So again, what we're going to do here is we're going to do 3 times 3, and that's equal to 9. And so then what we have here is we're going to still have the -5, but it's going to now be to the power of 9 because we multiplied the two 3's together. Those are the 3 laws that we came up with back in Learning Goal 20. The fourth one that we're going to take a quick look at is over here. And so we will go through this one as well. If an exponent is applied to a fraction, ooh, we get fractions now. I know, everybody's favorite, right? If an exponent is applied to a fraction, which is inside the brackets, both the numerator exponent and denominator exponent are multiplied by the exponent outside the brackets. Now again, this isn't brand new. We've done this before. We did this right up here in 3. Okay, but now we're just dealing with fractions, so it kind of adds a little bit extra to it. And so it's just as a reminder of how we go through this. So what this tells us here is that we have the fraction 2 over 4. I know it's not simplified. Apologies on that one. I might have to change that in my next set of notes there. Okay, we have the exponent, or the fraction 2 over 4 to the power of 3. We can write this out. So we're going to apply the 3 to both the 2 and the 4. So this can be written out as 2 to the power 3 over 4 to the power 3. Okay, so 2 to the power 3 over 4 to the power 3. Now again, if we ask you to evaluate it, we can actually evaluate it. 2 to the power 3 is 8, 4 to the power 3 is 64. 8 over 64 would be 1/8. But that would be a way of applying the power, okay, or the exponent into the fraction. In this case here, you'll notice how the numerator of the fraction already has an exponent to it, so it's 3 cubed. Okay, so what that means is that when this 2 is applied in, it's got to multiply to the 3. So what we're going to get in that case there, let's get it over here. So in that case there, we're going to have 3, and now 3 times 2 is 6. So it's going to be 3 to the power 6 over 4 to the power of 2, because the 4 only has a 1 on there. So we just multiply the 1 by 2, and we get 4 squared. So 3 to the power 6 over 4 squared. Now again, we could solve that if we really wanted to, but in this case, we're not going to worry too much about solving that right now, unless I ask you to evaluate on your assignment.